Wait, to college? Is it traumatized? You picked it up. Ew. That's so. Why would you?
All right, let's get to math class. All right, quiet, please. Questions on your homework? Questions on your homework? That's what I mean. Okay, no questions? Yes, Genevieve. Hush, guys.
No, I don't. What's it called? I don't think I'm there yet. Because I was.
Okay. But remember, if you were watching it after I posted the video, then you're a day behind.
Yeah.
All right, but for everyone else, 11.8, we good? All right, let's go over the answers. All right, 5 through 18 all. Number 5 is 1/15. Nope. 1/15. It says both marbles are orange. How many oranges are in the bag? There are 3 orange and there are 10 total. So the first one you draw, you have 3 chances out of 10 to get it right. Now, remember it says without replacement. So now 1 orange is in your pocket. So the second time you reach in there, how many oranges are in there?
Wait, you said that. It would only be 1/10.
Hold on. So the second, remember, probability is how many chances to win. There's 3 oranges in the bag. You have 3 of them, right? 10 is how total things that can happen. You can draw everything other than orange marbles there. The second time you reach in there, how many oranges are in there? Out of 9. There's 1 in your thing, so there's 2 out of 9. Multiply. You can also reduce. What do you get? 2 out of, which reduces to 1 out of 15. There's only 1. You're only grabbing 1 marble at a time. Yes, you're not reaching in there and grabbing 2 marbles. You're grabbing 1 marble. You misheard what I said. All right. Number 6 is 7 out of 15. Number 7 is 7 out of 30. Remember, we're talking fractions here. Number 8 is 7 out of 30. And once again, the fractions thing, 7 out of 30, what does that even mean? Right? As a human being, we would much rather hear it as a percentage. Now, probability, I mean, it's nothing wrong with 7 out of 30 being the probability. But more likely, if you're talking to a regular person, hey, what's my chance of this occurring? You change that 7 over 30 to a percent. Number 9 is 7 out of 15. It's all the way through 18. Number 10 is 3 out of 11. Number 11 is 2 out of 11. And number 12 is 6 out of 11. Number 13 is 3 out of 10. Number 14 is 1 out of 10. Number, give me that. What number?
15.
14 was 1 out of 10. 15 is 3 out of 5. 16 is 3 out of 28. 17 is 5 out of 14. And 18 is 15 out of 28. If you are literally copying down the answers and there is no work on your paper, do not turn this in. You don't get to those numbers by picking them out of thin air. You get those numbers out of You get those numbers out of doing the work, right? Yes.
What was 16?
16 is 3 out of 28. All right, where did I leave off? All right, you see us coming around to grab your homework. We have finally made it to the last section. Unfortunately, we get 2 more formulas to further confuse us. And unfortunately, now we go to CMAS testing, not CMAS prep, starting tomorrow. And we get 2 more formulas. And then we forget about this stuff, unless there's a specific question on CMAS, which there could be. We forget about all this stuff, and we take our CMAS test for a week. Then we take a 3-day weekend, and we come back, and then we'll get the chapter test. That means we're going to do 2 days of review. We got to hit this review hard because chances are You might lose some of the knowledge that we worked so hard to get. I will promise you that the chapter test will be exactly like the chapter reviews. You take the chapter reviews and you blow it off, and you think that you're going to remember something you did 3 weeks previously. The first thing that we did, we got problems. So to scare you, the following slide. We started off by simple probability. These are all the formulas that we know so far. Simple probability. How many ways to win over everything that can happen? That's the first formula. Then we said, well, wait a minute. There's two things can happen. You can play one game, but if you take one turn, or you could have multiple turns. So here's what can happen. If you take one turn, well, you might have 2 things that could happen. An or. Hey, what's the probability I grab a blue or an orange marble in one turn? Well, there's the formula. Probability of orange plus probability of blue, or whatever it was. Well, wait a minute. Sometimes you have, instead of mutually exclusive events, you have overlapping events. What's the probability that I grab or I roll a 2 or an even number? Well, both of those happen at exactly the same time in one turn. So we get a different formula. Probability of A plus probability of B minus the overlap. Okay, so now we're up to 3 formulas. And then we said, well, wait a minute. You can play more than one game or more than one turn. So you're taking multiple turns at the same game. Well, 2 things can happen again. One, those 2 things could be completely independent. We put the marble back in the bag. It's the same game over and over again. Well, now we multiply the 2 probabilities together. And then last night's homework, without replacement, different game each time. Well, it's probability of A times the probability of B, given that A just occurred. 1, 2, 3, 4, 5. But wait a minute, we also had combinations. There's the formula. Permutations, 7 formulas. We get 2 more today, so for a total of 9 formulas. Okay, it's hard. Oh, by the way, it's probably 10 because we also have the counting principle, right? I don't put questions on the counting principle because the counting principle is used in many of these formulas to begin with. All right, so that's your scary slide. Here's tonight's homework. Copy it down. 2 more formulas. They're easy today. Yes. Talk to your partner crying.
That was on accident.
Okay.
I had to go the other way around because you always go up here. So I had to start off back there.
Did you collect her homework?
No.
Because she didn't have it.
Oh,
I'll do it later.
I've heard that before.
Yeah, but I started doing like the homework that I've been missing.
Be
Yeah.
better if you were caught up. Use your student advisement wisely instead of talking.
We're not allowed to.
Well, then what, do you stare at the walls?
Yeah.
Man, do your homework. Good Lord.
After you do it,
I could start pointing fingers of the people that aren't doing their homework. Somebody's doing their homework and they're not even turning it in, apparently, according to Mom.
Wait.
How did you know I was talking to you?
Wait.
Oh, for
You don't know.
red-handed.
And your sister was rummaging through your locker yesterday. And I walked out of the door, your locker's right there and stuff, and I saw a little Priscilla. What's her name?
Julie.
Don't call her that. That's
Julie.
disgraceful.
She kind of looks like you, though.
She does.
The only reason I know it was her sister because she looks like you.
Exactly. That's why we call her Mini Priscilla.
Millie.
It's
See, even other people do it. But anyway, I walk out the door and there she is, and I was like, before I could even say, "What are you doing?" She goes, "This is my sister's locker." And she was with some other girl too.
That's Sarah's little sister, Kara. Probably.
What were they doing?
I don't know. But they were going through her locker, and like I said, it looked suspicious. And then they said, "This is my sister's locker. I'm supposed to be getting stuff for her." And then the other girl said, "Man, is her locker messy."
Yeah. And most of that stuff goes to my locker.
All right, here we go. The 2 formulas I said today was, well, each individual day, they're pretty simple, right? It's not too bad, but all together it is bad. All right, this one's called estimating probabilities. This one has a much more useful context, as you'll see here in a little bit. So I like to say this is probability of real life, like what happens in real life. All the stuff we're doing is, well, there's a game involved. Well, game is fun, pastime. It's not real life. Real life, we do lots of things. For instance, I don't know, Jaden goes up and he tries to throw paper into the trash can almost every day in my class. Sometimes he's successful, sometimes he fails at it, okay? A useful thing would be to calculate that probability. All right, write this down, please, box 1. We're going to be doing something called expected probability. Now, be careful. Expected probability doesn't mean this is what must happen. Expected probability is what should happen. If you try it enough times, your expected probability meets up with what your calculated probability should be. It's a pretty big thing in math. But expected probability doesn't have to, especially if you only do it a couple times. And basically, we define expected probability as the likelihood of an event occurring based upon previous attempts. Something happens that you do frequently. Well, you can simply count how many times you win at it, how many times you lose at it. That's your expected probability. We get 2. Remember I said there's 2 formulas. Well, this one comes in 2 flavors. It's the same formula. I'm going to need to write this down. One is called probability of success. Probability of success, as you would think, would be, well, how many times did you succeed versus, or ratio, versus how many times you fail. Or number of tries, number of tries. Yeah, that would be completely wrong. That would be odds. So he goes up the trash can, he tries 10 times to throw away a piece of paper, and he succeeds at 9 out of the 10 times. Well, 90% of the time he's successful. I mean, this is kind of what we think about in life. Free throws, the same thing. You know, who's a really bad free thrower in our school?
Me.
So Landon is a what percentage free throw thrower?
0.
0?
1%.
All right. So he's never made a free throw?
No.
Okay, so he's more than
Also,
0.
never got
Okay. If this is the probability of success, what would be the other one?
Probability of failure.
So how would you define probability of failure?
I do not.
How many times you fail over how many times you try. So there, it's the same formula. We just call one the success, one the failure, but it's the same formula.
So basically, like,
It just depends which one you care about, right? For instance, if you're very successful at something, probably you want to do the success one. But if you're more likely to fail, then you just, well, he fails 96% of the time. You know what I'm saying? You can either say that you fail 96% of the time or you succeed 4% of the time. Kind of just depends which one you want to frame your statement in, success or failure. It's the same formula. It's just a ratio of what the success criteria or failure criteria is over how many times you try. Okay. Once again, we would prefer if you write this as a percentage because, well, we don't like fractions that much. We'd rather have it written as percentage, but it's calculated as a fraction, right? Anybody lost on this? So this entire homework is going to be about real world things. Something happens and occurs. You count how many times it occurs. Those are your number of tries. And then whether you're calculating the success or failure, that's the other part of that. It's a fraction. You're done. Okay, so example, this is a pretty quick class. Clearly this is not Landon because it says Mark can make 75 out of 120 free throws. Okay. What is the probability he's going to make the next one? Well, I don't know. How are we going to know what it makes? So what we're saying is we base your probability of making your next one on what you've done in the past. And would this be success or failure? Probably we could do either one, by the way. You want success or failure criteria? Success, right? Because we want to know if he makes it or not. Okay. Well, if we're going to use success criteria, well, then we use this one. Well, how many successes has he had? How many times did he try? Okay, reduce that fraction, change it to a percent. So what we say about is he going to make the shot or is he going to miss it?
Make it.
Is he more likely to make it or is he more likely to miss it?
Miss it.
More likely to make.
Where are you getting miss it from?
Because it's like it's more than 50%.
Okay, it's more than 50%. Now, the closer you get to 50%, what would you say? Right. I'm saying then, therefore, you probably don't want to. You want to be crossing everything you got. If the game is on the line. If he's a 90% free throw player, there's some of those in the NBA. Well, then he's probably going to make it. You want that guy to take the free. So you want that guy to get fouled, right? So if you're the other team, that's why teams keep track of this stuff. Who do you want to foul?
Me.
You want to foul this guy right there. He only makes the shot. I mean, there's not too many NBA players that are less than 50%, right? Famously, what was the guy that was famously really bad at free throws? He's an announcer now or commentator. No, the big guy. Shaquille. I don't know what his percentage were. They weren't as bad as what people make it out to be, but he was not a good free throw, for the NBA, right? I don't know what his percentage was. We can look at it at the end of class, but that was the guy you wanted to foul at the end of the game.
Yeah, that guy can jump from free throw.
All right, but you got to take a free throw shot from the free throw line. You can't dunk it, right? Not allowed to.
But actually, you could. You can hit the rim, and it bounces back to you.
That's a different thing. That's after the free throw.
That's still.
Agreed, but you can only get 2 points then.
Yeah, so it's more than one.
You can get 3 points in a free throw if you play it right.
Well, only if
You make the first one, and then you do your little trick, and then you got a chance of making 3. But it's very little. You have to be very good at that. Okay, here's another one. Sarah has been at that. This is really it applies to things more than sports. You'll see a couple here in a second. Sarah's been at that 30 times a season. By the way, who plays baseball, softball here? What's a good batting percentage in the major leagues? You get paid millions of dollars if
you hit a home run.
batting percentage.
Oh.
What's a good batting percentage?
75.
50.
There has been no one in the history of baseball that has ever had a 70% batting average, ever.
Really?
Do you want to know what you get paid hundreds of millions of dollars for? Hundreds of millions. If your percentage is
30. 50?
30%.
40%.
What?
There's only been one player in the history of baseball, Major League, to ever get 40%. Ever. One player. I forget his name.
Well, the average then would be like 25 to 30.
30%, you are considered a superstar, right? If you're a pitcher, your percentage is single digits.
What if 100%?
Pitchers are the worst batters at all time. They never practice at it. But an average is somewhere between 20 and 30% in the major leagues.
Wasn't like Babe Ruth?
Babe Ruth did not have. He was a home run hitter. He wasn't an at-bat guy. Usually there's that kid that can just spout these statistics out. But not this year, apparently. All right, so Sarah's about 30 times a season. She safely hits. That means she gets a hit, right? Single, double, triple, home run. She safely hits 9 times. What's the probability that she's going to get a hit the next time at bat? Okay.
Yeah.
Well, what do we want, success or failure?
Failure.
What success? We want to know if she gets a hit.
Yeah.
If you want to know if you get your hit means success. If it said, will she strike out, that's failure, right? So we're going to do success again. Okay. So how many times was she successful?
9.
Out of?
30.
Okay. Change that to a percent. 30%.
Told you.
So is she a good hitter?
Yeah. No.
Well, yes. Like I said, in baseball, 30% is very good.
Yeah.
Is she likely to get a hit? No. 7 out of 10 times she does not get a hit. 7 out of 10 times she does not get a hit. Now, obviously, you have to have this in the context of baseball, where 30% is considered really good. In high school sports, they absolutely have a higher than major league, of course, is the best. And 30% would be, hey, you're going to sign yourself a $20 million contract with that. But in high school, 30% would be pretty kind of average, right? You get lots of hits because kids aren't that good in high school. All right.
What do you mean?
One more, let's go. Last year, in the last 50 years, it has snowed on Valentine's Day. 20 times in the last 50 years, it has snowed on Valentine's Day. what's the probability it will snow this year?
100 times.
Okay. Do you want success or failure?
Failure.
Because we want to know, will it snow? If it said, will it not snow, there's your failure. Because we're asking, will it snow? The data, it says it snowed 20. Okay. So success formula again. So what's my numbers? 20 out of, okay, so that's 2 out of 5. That's what percent? 40%. So is it going to snow?
Yes.
More,
Most likely, yes.
less likely, but I would not bet against it, right? This was probably the worst one because remember, weather doesn't care about what happened last year, right? Free throws do what happened the last 50 games. Weather is probably the worst one to use this on because weather is not dependent upon what it did last Valentine's
You
Day.
guys must be living like in Antarctica or Russia or something like that. 'Cause if it snows on Valentine's Day, I feel bad for you.
When is Valentine's Day?
February 24th.
In February in Colorado, is it likely or unlikely to snow?
Unlikely.
Bruh.
We live in Colorado, so it's
Well,
gonna.
it snows for 50 years.
Yeah, but it only snows
No.
from like
It snows 20 times.
20
in 50
times, and
years.
there's plenty of places in the United States that it will probably snow on Valentine's Day because Valentine's happens in February.
it only
Alaska.
snows like from
Maybe you've never noticed this, but come Christmas time, have you ever noticed what furniture and jewelry stores do?
No.
they make it snow.
I'm sure Miss Garland knows.
They make it
What do
snow.
furniture and jewelry stores do at Christmas?
They make
They
it
make
snow.
everything
Let her
red.
talk.
Oh.
No?
They start doing those, if it snows so many inches on blah, blah, blah day, you get your thing for free.
They literally do that in our state. So they'll say, come to our store, buy $10,000 worth of furniture, and if it's not going to be if it snows, it's going to be if it snows 8 inches or more on Christmas Day or whatever, then you get free furniture.
Wait, but that's not gonna happen.
Duh! Right? That's why they say that. That they say that because they're pretty darn sure, but they buy insurance just to make sure this doesn't happen too. But
Do they do that in other states?
I'm sure they do. It's a popular thing for people to do, and people are like, well, heck, why not? I was kind of thinking about buying a couch, and then you hear this ad on the radio or in your car or something like that. It says free furniture if it snows 8 inches on Christmas. You're like, hey, maybe it will. I'll buy the furniture now.
How tall is 8 inches?
What?
How tall is 8 inches?
How tall are you?
Like
5
feet.
5, 7.
So how many inches in a foot?
I'm taller than 5 feet.
I will really enjoy once I start getting students that have been at our school for 12 years. You
like
don't know how big an inch is?
Wait until you-
He really said he was 5 feet.
Mm,
Oh, no, I'm 5 feet.
It's broke.
Then you're not. I'm 5 foot.
that's an inch.
No, that's 8 inches.
You are.
That's it.
Wait, what? I thought there were centimeters though.
There are.
Where?
On the other side.
But those are inches.
Oh my
Those look like
God.
inches.
Bruh.
All right,
Dollars.
here we go.
Five.
Now, notice on the previous one, we only did successes. Now, failure comes into play at times. So one of the applications is this. Anybody know what this is?
Xbox 360 circle up down.
Yes.
Well, who can explain this? Who can explain this to the noobs in here? All right, Grayson, you talk, everybody listen. Thought you said you could explain this. Angie, can you explain this? Don't raise your hand if you can't explain this.
No, like, it's like how, I don't really know how to explain
You guys are all noobs. Here's the explanation.
You died.
When the Xbox 360 first came out, it's not made anymore. When the Xbox 360 first came out, it had a problem. And what would happen is you'd be playing, all of a sudden, no playing no more. And you looked at your Xbox 360, and this was literally called the red ring of death. And it was like, if you saw that, it just meant you just bricked your 360. There was a manufacturing flaw. It had something to do with the main computer chip, and it's not glue, but they put this stuff on it, so that when it gets really hot, that it sends the heat through this piece of metal. The metal is called a metal heat, S-I-N-K, heat sink. And a heat sink draws heat away from the chip, and it lets it go into the air type thing. There's also a fan as well too. But they had a problem with the heat sink and the fan separating from the chip, so the chip would get too hot and just makes them burn up. That would cause a red ring of death. So what's that got to do with us? Well,
Where's the possibility?
if you worked in the factory that made the Xbox 360, and this is for all factories, not just that particular factory, you are always interested in how many things do you make that don't work? Because if you want to make a good profit, you don't want to ship things that don't work. It is estimated that Microsoft, Xbox, Microsoft, lost $1 billion because of the red ring of death. If they had had better testing in their factories, it wouldn't have happened. Okay, so those two words, box 5. The first one is called sampling. Now, in the factories that make this, for instance, the new Xbox or the new PlayStation, they can't test every single one that comes off the factory.
Why?
There's too many of them. They don't have enough time to test them.
But they're selling out like wildfire.
Agreed, but how long do you think it takes to test something?
Like 20 seconds?
No. They test these things for days. Okay.
But like,
So what they do is, instead of taking everything that comes up, and by the way, if it takes days to test it, the chances of it getting scratched up or bumped because they're testing it increases. So what they literally do is, instead of testing everything, they take a sample of the numbers that are produced. I have no idea how many they make per factory. Let's say they make 1,000 a day. They make 1,000 a day. They don't test 1,000. They might test 10 of them. But they'll take 10 and they'll take a sample out of the 1,000. They'll take one, maybe the first hour, 2 the second hour. They'll just randomly, it has to be a random sample, and they test them. They're going to find out whether it works or whether it doesn't work. The sample represents the entire population of ones that they built that day. Second word there is what's called expected outcome. These are going to be conclusions that you draw based upon your sample. You take 10 out of 1,000 and 9 of them don't work, you can be pretty darn sure that 90% of the ones you just made will not work. It has to be a random sample, though. It has to be a good random sample. If all you do is pick the ones that are built on a Tuesday, they probably all work. If the only ones you pick are Friday, 20 minutes right before quitting time, chances are people are more interested in quitting, going home for the weekend, than they are building a quality product. Well, that's my personal belief. If I ever buy a product, I always want it not built on a Friday right before the weekend. All right, does everybody have this written down? Jaden?
So I had an Xbox.
No. We're back up here. So sampling and expected income. This is what all factories do to ensure that they produce a quality product. By the way, we're about to take the state test. The test does a sample of people that take their test. And what happens is, if they find in that sample some weird things are going on, they can make conclusions for the entire population based upon that little sample. All right, so it sounds complicated, but it's actually pretty simple. So it says a factory made 5,000 calculators in one day.
Woo, that's right.
To control for quality. They don't want to send out 5,000 if they're broken. They want to see how many are broken. To control for quality, a daily random sample of 200 is taken and tested. Of these, 6 are found to be defective. So they build 5,000, they pull 200 off the assembly line, and they test them. Of the 200 they tested, 6 of them are screwed up. How many of the 5,000 are screwed up?
6.
No.
Yes, because 6 are defective.
6 out of 200.
Yeah.
So we need to figure out what that is as a percentage.
Wait, like
So let's see. Number of failures was what?
6.
Out of 6 out of 200. If I change that to a percent, I get 3%. By the way, when the PlayStation, I have only because I'm a PlayStation person, when the PlayStation was first being produced, it was reported by Sony that 40% of them were messed up.
That bad.
But by the way, they tested them to figure this out, so they didn't ship broken ones. But at the factory they were initially making them at, they were getting what's called a very high, what's it called? Failure rate. 3% are screwed up. So how many calculators don't work?
Too many.
3%.
60%. So
How many calculators that day don't work?
30% of calculators.
Where are you getting that number from? 3. How did 3 turn into 30?
Because of 3 over 100.
How's that turn into a 30?
Because you take 3 out of 10 to 3 out of 30.
That's not 3 out of 10. That's 3 out of 100. So 3% of our sample are broken. So how many calculators are broken? Can anybody figure this out? 100% true, but there's an easier way of doing it. But what you said is true.
0.3
3%
times
of-
5. Oh wait, no. That's
Okay? Say it again, Genevieve.
What's 3% of 5,000?
What's 3% of 5,000? How do we mathematically calculate that?
0.3 times 5,000.
Close, but no. It's not 0.3.
0.03.
0.03 times
5,000.
5,000. Write this down. The second and final formula you need is what's called expected failures. Expected failures is, now this says the number made, but it's whatever your population is that you either produced. It's like saying we have 1,000 people in our high school. They all take the same math test. I don't want to grade 1,000. So I take a sample and I grade 10 of them. One of them fails. Well, then if as long as it's a random sample, I can predict that 10% of the students fail. And I take 10% of the 1,000. Failure rate has to be written as a decimal. Has to be written as a decimal, not a percent. So you can't multiply by 3. Jackie said we got to multiply by 0.03.
And then it's multiplying.
It is. So we take the 3%, we multiply it by 5,000. I get 150. So they build 5,000. 150 of them are broken. Now here's the deal that you have to make as a business owner. Do you ship 5,000? Yes, the answer is yes, you do. So guess what the business owner is saying to themselves? I'm going to ship 5,000 calculators knowing that 150 of them are wrong and bad. And this probably happened to you or your parents at some point. You go to the store, you're buying this nice new gadget, you bring it home, it doesn't work. Right? And that's because there will always be a failure rate of some sort. Businesses try to make that as low as possible because they lose money. That's why you have this, money back guarantee, or we'll fix it, or well, you got to mail it back to the company. Xbox 360, I'm sure that the story Jaden was trying to tell us was, I had this 360, I got the red ring of death. I called up Microsoft and I said, hey, you got the red ring of death. So they sent me a box in the mail, cost them money. They had to ship it to someplace, cost them money. They had to hire someone to fix it, cost them more money. That was all money that they had to spend, Microsoft, that they never got that money back. So that's all lost money for them. So the business owner just makes the basic calculation, which is, if 150 are going bad, I have 2 choices. I either can fix my assembly line so that I have a lower, obviously that's the best thing to do, or they can ship 150 and charge more for the calculator so that they can still make enough money to cover the fact that 150 go bad. Now, here's the other problem. They get a reputation of building CRAP, right? And you're not going to buy the calculator in the first place. All of that are things that weigh upon the business owner. We got it? By the way, this was the formula again. I'm sorry, I had an extra slide for it. So total number is your population. It could be things you make. It could be students. It could be anything. And then your expected probability has to be written as a decimal, not as a percent. Yeah, you're going to calculate your expected probability as a percent, but then you change it to a decimal to do your expected outcome. You're trying to figure out how many things are going to be bad or good if this was a successful one. Remember, this whole thing could be flipped around by saying, well, how many good calculators are there going to be? Well, if we do a sample and 3 out of 200 are bad, then what, 197 are good. It's one of those glass half empty, glass half full type things. All right, we got everything written down that we have written down. We're going to do a couple of these. All right, Jordan has a serious issue throwing paper into the trash can. Last week, in 20 attempts to throw paper, Jadron missed the can 15 times. If Jadron were to throw 50 pieces of paper away, how many pieces will be on Mr. C's floor? This is from the book. I did not make this up.
Yeah, you did.
All right. All right.
It's not in the book. I have the book right here. This is not in the book.
All right. So let's see. We got to figure out his failure rate. So how many failures does he have?
20,
Out of,
50,
say that again.
20,
How many times did he fail?
50,
What? Say that word again.
50.
50. It says that in that text that he failed 50 times.
Oh, no.
How many times did he fail?
15,
15 out of
20.
20. So he throws 20 pieces of paper. He attempts. He fails 15 times.
That's 75%.
He fails how much? What is it?
75%.
So 75% of the time he fails. Throwing paper away. Okay.
Wow.
So if he throws 50 pieces of paper in total away, how many pieces of paper will be on Mr. C's floor? What do we do?
75 out of 100. Or Mr. C.
Yeah, but he only throws 50.
Oh.
He only throws 50. I agree with what you said, though. That makes the math really easy, though. Well, what do you do mathematically? 0.75 times 50. He's throwing 50 pieces of paper away. His failure rate is 0.75. So how many pieces of paper are on my floor?
37 and
I need a new vacuum cleaner, right?
Gee.
Jaden, what are you doing?
It's
Right.
No, it's Jadron.
Jade, why do you think this is about you?
How did you get 30?
All right.
Wait, how did you get
We never said it was you.
You take his failure rate and multiply by how many pieces of paper he's throwing.
Okay, but where did you get the 50?
It says right here, last week he threw 20 pieces of paper away. 15 of them wound up on Mr. C's floor.
Is this real?
No, this is not real. Every year I always have to pick someone, and Jaden was the one that last week tried to throw paper away and went on the floor. All right.
Jaden.
Last year it was
Shepherd.
no, Shepherd wasn't in this class last year.
Oh, remember last year when
Last
there's
year it was, I forget who it was.
Halo thing?
All right.
And it was like Shepherd.
All right. Could have been. All right. Let's do one together. Last one, box 6. Last one. Oh, marble bag. All right.
Yeah.
Says that they have a bag of marbles and there's 1,000 of them.
This isn't number 6. This is number 7.
Is it? Okay. I labeled them wrong. All right. Number 7. There's 1,000 marbles in a bag. Notice it doesn't tell us how many are blue or how many are red. It just says there's marbles and they're blue and red, but it doesn't tell us. It's asking us how many red and blue marbles are there, but it doesn't tell us how many. We can use this process with taking a sample to predict. So you're not guaranteed. It's just a prediction. It's a pretty good prediction, as long as you have a good random sample to predict how many red and blue marbles are in the bag. So what's my sample? How many marbles? 20. And what did we find in that sample? 16 blue and 4 red. So how many red marbles in the bag? Well, first off, we got to figure out how many red were in our sample. How many red were in our sample? Out of 4 out of 20. So that would be a percentage of 1 over, which is what percentage? 5 goes into 1, 20%. So 20% of our sample was red. So how many red marbles are in the bag? 20% are red in the sample. So how many marbles are red in the big bag? 0.2 times, which would be, you should be able to do that in your head. The 2 times a 1. Well, it can't be 2 red marbles. 200. So 200 of them are red, so how many are blue?
800.
Well, you could use the same process again, or use some common sense. 200 of them are red, how many are blue?
800.
You get that? Now, we could do the other process, which is reduce that to a percent. And 80% times 1,000, 0.8 times 1,000 is 800. Or use a little bit of common sense of 200 red and 800 have to be blue. Are you guaranteed that if we literally count the marbles, that 2 of them will be red?
No.
We're not guaranteed, but pretty sure. Pretty sure. The fewer marbles there are in the bag, the larger your sample size has to be in order to be accurate. The more marbles you have in the bag, you know, there's 330 million people in the United States. When they do a sample, you probably heard, hey, we took a poll. We took a random sample of Americans. They don't do it to millions of people. There's 330 million. All they do it is to a very small sample. But the people they choose have to represent everyone in the United States. So it has to be a really good sample. There's a whole level of jobs and science and math all revolving around taking polls and surveys. If you're interested in that sort of thing, there's some good money in it. Because every 2 years, guess what happens?
Raise.
Every 2 years in our country, guess what happens? Every 2 years, guess what happens in our country? We have what's called an election. Every 2 years. And every 2 years, for months upon months, all you see on the news is a recent poll of likely voters. Those are all people, mathematicians, pollsters, scientists. Their whole life revolves around, boy, it's a pretty good, if you like that sort of thing. That would cause me nightmares if I had to do it, because I don't think it's fun, but other people do. And it's well-paying jobs too, as well. Statistician, pollster. That's it. That's the whole class. Questions? All right. Get started on your homework. Thank you, Jaden, for allowing me to use you as a example. That's very good. Holy cow. I couldn't do that. That's really good. Are you going to take art next in freshman year?
I'm not sure I'm gonna be there.
Oh, if you do, make sure you sign up for drawing because you're really good. All right, no one is live, but e-learners, if you have any questions, send me a chat or email.